Hello everyone, I'm Xiaogan. Okay, in this lesson, we'll start writing this encryption algorithm, which is a comparison encryption algorithm, to parse this URL. Actually, don't think this lesson might only be a few minutes long. In reality, if you've never written this before, it will take quite a while. First, we have a URL coming in. We split the URL, we could hardcode this part. But for generality, we didn't hardcode it. Then this URL, we split it using the slash method. Perform a split after splitting it like this. After splitting, it will be divided into several pieces of data. You can see this URL. It looks like this. It will extract these segments. So first of all, this UI domain thing is its domain name. The first one is the domain name. Okay, next, we need to take the domain name after the return text. The domain name is this. This part is extracted, and this is it. It is the first element. Then we need to concatenate the following elements. Just concatenate this string. So how do we concatenate it? Then we prepare a string called URNPath. We just need to iterate over the following lengths. We let it start iterating only from after index 1. Then we let it add this slash. Then add the following index to it. After concatenation, it becomes like this. It becomes this one. Okay, after we handle it like this, now we need to start doing encryption. It says here, first, you need to prepare this signature key. So I'll prepare this host first. Obviously, for this host, we just need to add the domain name, then add an, and the second is this time. As for this time, it actually looks like this. Like this. So for this time, we will directly, this is the HTTP time, right? We just let it reach UTC, then convert it to this HTTP time. Okay. And this time actually depends on whether it is verified later. Okay, this time. See, if it provides this UTC time, generally, it seems you don't need to worry about it. Just write it like this. Sometimes you need to confirm this time, because if it's not clearly written, whether you are using domestic time or using foreign time, you actually won't be sure. Okay. Then we splice this time into it. After splicing it in, we now prepare this require inline. Require inline is actually just this one line. We can completely paste it over. But we don't paste it because we want this interface to be used in different places. So this require inline. Obviously, it's a post. Plus the address we are accessing. This one at the back. Create this address yourself. Then add HTTP. This 1.1 is fine. Then pay attention to these places. There are spaces. Okay, so actually like this, our original signature is to take these three brothers, add them together. Just these three brothers, add them together. That is our original signature. Next, we are going to use this algorithm to encrypt it. So the corresponding one is actually this. Use this algorithm to encrypt it. So here, we need to give it an encryption. We don't have this encryption method yet. Let's write this encryption method, because what we wrote here is actually the original encryption method. When we use it, we definitely don't want to call such pointers. So we need to do a simple internal processing for it. Okay, so let's simply write it here. It returns the encrypted information, and this is APV secret. This is the data you want to encrypt. Then here we change this. If we look at this name, it should be HMC. HMCT 156. Okay. Let's give it an XG, very high, so we can distinguish them. Okay, with this algorithm, we call it here. Back here, we pass in our secret and the data to be encrypted. As for encryption, it mainly calls the one above. Then how do we write this? Let's see, actually we write it like this. First, we take the string we passed in. We convert it to UTF-8. Okay, after converting to this UTF-8 structure, then we just need to call the method above. Let's call it. Okay, the structure returned here is clearly it. And here it's Shenfei BSSHD256. We can take a look. Yes, and here it should be this. Let's press enter here. Let's check. Press enter. Here we first pass in the data we want to encrypt, the length of the data. This method doesn't exist. Strange. Let's check it out. We made a mistake here. It's this one. It was pasted wrong like this. It was pasted into this return struct. That's the reason. And then here, it's the input data. And here we need to use this key to encrypt it. After the encryption is done, we need to process this string. Because this string requires a base 64. Yeah, because after you encrypt it here, it still needs to be base 64 encoded. So here we also need to base 64 encoded. Then the base 64 here is a bit special. It no longer goes through this. Let's first wrap this input key with base 64. It no longer goes through F3. It uses this kind of compression in binary format to encrypt. It seems to be 32 bit, then 32 of them. And this is one of its addresses. You see it like this. Okay, then after the encryption is complete, we return this character string back. This way, our signature is handled through this method. Then we come back here. Okay, with this signature, we need to proceed to the next step. Get our verification information sorted out. As for this original signature, we can just concatenate it here. You see, we take this part down here. It looks like this. This step corresponds to 淘百. We just need to piece this together. The corresponding step is to replace this part. Replace it with our key. Note that here we use secret. Here is the key. And this is its algorithm. And how it assembles this header information. And finally, this signature, our encrypted signature. Like this, it's base 64. First, sign this. After a 1256, then process it like this. And after this processing is complete, finally, we verify this after encryption is complete. This thing is base 64 encoded here. Okay, after this processing is complete, actually, we are basically done with this. And after this is done, we need to output our URL. This URL, we output it. So regarding this URL, we can also output the protocol from other places. As for this protocol, it is actually equal to whether it is HTTP or HTTPS. We will replace the part before it for now. Because when it is extracted, what is extracted is actually HTTP, followed by a colon. Replace the colon in place. Then putty. This is not an in-place replacement. This is a replacement that returns a new F3. And then there is a repressing line. This one is the in-place replacement. Okay. So our URL here is actually quite simple. It's the URL for our output file. Then we'll have it concatenate this long string of stuff behind it. Okay, now, something worth noting. We still have one method that hasn't been written yet. This is called URL encode, because you'll notice that here, after it's all concatenated, we can see it's concatenated this after that, actually here. Here you'll notice it uses this 3% method here. So this is a type of URL code, because here, there are some spaces. If you type spaces here, it won't recognize them. You need to convert to them. So this is called a URL code. And what is this URL code? Actually, we wrote it ourselves. We write this URL code into our base as well. This URL code is essentially a string we pass in. And then we perform a simple replacement on some characters in the URL that we consider illegal. That should be it. So actually I calculated it. The engine's underlying system should also have this. I didn't look into the engine's underlying system. We just searched online. Roughly, we need these few symbols. Then just replace them one by one. Okay, so let's paste this URL code. Paste it here. Right here. Then replace it. Let me check this URL code. Okay, no problem then. Finally, we have essentially completed the execution. Let's check again. So after the URL is finally assembled, you can see it is actually .string plus data plus host. So there's no problem. Then here, we only need to process this time. Because the other positions are fine. This has all been base 6.4 encoded. Well, this is actually just a domain name. There shouldn't be any need for adjustments. Okay, then let's compile it next. Compile it. Okay, the compilation passed as well. Then we need to do a simple test here. Only then will we continue writing the rest. So since the signature verification has passed here, we need to set up an HTTP response reception here. So first, the first thing we do upon receiving it is to print this log. Because if you don't print the log, how would you know whether this thing has been sent over? Okay, so after it has been sent, we still need to check whether it contains this content. Is there any content? Okay, then we can just print this content out. Then we increase the intensity a bit, otherwise we might not be able to see it. Good, now let's start a test here. Good, let's start it here. Good, I've already started it here. Then we need to go to our this plugin. Look in the Peter plug, because this code should be called here. Good, here we mainly generate an image here. Let's see where the image is. Here. Then we generate the image. We call it xg. XF. That's it. Then we need to connect it to the success pin. Then we prepare 3 parameters here. Here we need to connect this thing over. Okay, then it's a PNG image. Let's straighten the line a bit. That's how it's done. Good, after straightening it out. We can skip writing this part for now, because this pin hasn't been implemented yet. Right, then we'll take this side, fill in these 3 string variables. And then this thing, you need to obtain it from the iFLYTEK official website. Remember to register. This service is free. Then we can just fill in the key information here. Okay, let's not fill it in for now. Right. Not filling it in for now. And then when you test this part, if it's inconvenient, you can write a method to convert this to embed a local image. That is, if you don't have a camera, this thing might not be usable. You can write a fail a class and then convert it into a TLV binary data. And then passing it locally is also fine. Let's start it here. We turn on the camera. Then we generate the image. It was generated successfully here. It succeeded here, but it seems we need to check if it was called here. Let's click it again. It was called here, but it seems there is an issue with our log. Let's check what the reason for this is. Let's put a lock here. Check it. Okay, then let's click again. Enter. Good, everything here is fine. Here. Hey, okay. It seems on his side. We seem to have missed something just now. It should be fine now. Mainly, let me explain to you. We missed a line here. We missed something here. This activity, this part is missing. What is the reason for the omission? It is because we originally defined it here. We had to define this ourselves. Then we executed this method in the parent class. And our subclass did not write it. So when we copied it over, we missed it. So let me remind everyone to pay attention. This part, we need to add these 3 lines of code here. This part is missing, and that will cause it to not actually execute. Now, our project has started up. Then let's open this blueprint here. Yeah, you can see we are still the same. We just take this refined data, connect it to this place. Then take these 3 pieces of data. It is still empty, not filled in yet. Right, we just want to see whether it can access iFLYTEK. Then next, we click. We turn on the camera. Then we generate the image. Okay, this is a breakpoint. We ignore it. Then we can see it is still stuck here. Let's see what's stuck. It should be that we have a few endpoints not closed. Then you can see we click again. Okay. Here you will find it's a level 1 service error, right? Because this thing simply doesn't exist. That is, it cannot verify these hosts. These signatures are. That is, this problem is very common. It's that your signature is incorrect because you don't even have the secret key. So now we will take the secret key and call it to this place. Then I'll pause here and everyone call it on your end as well. Then you must go and apply for registration. This interface can be used for free. Alright, I've already pasted it here. Now let's try it again. Let's test it again. Okay, let's start it. Then we turn on the camera. Okay, let's start it now. Then you'll see that it has been received here. You can see this is the data returned. Okay, we'll stop here for now. We have succeeded, right? Yes, okay. Note that here, it seems we were debugging. We missed 3 lines of code. That is, when we were writing the framework, we missed 3 lines of code. I wonder if everyone noticed this detail. When following along, if you miss this entire sequence won't execute later. This encryption and such is also fine. We'll end this lesson here. Thank you everyone.